Today I'm going to talk about FreeRider HD. Specifically, I want to talk about the way that FreeRider encodes and reads player-created tracks. Everything is placed using a coordinate system, just like the one you probably learned to use in middle school. On this grid, the center is right in the middle of a bicycle at the beginning of a track. Every power-up has an X and a Y coordinate pair that tells the game where it goes. Some power-ups also have a third value that tells the game how much to rotate it by. Lines have two X and Y coordinate pairs that tell the game where the start and end of a line is. FreeRider does not actually support curves, at least not in the way that we usually think of them. Instead, when you draw a curve, the editor tries to figure out how to make a bunch of lines come together to look like a curve. For a track like Chillwind Woods, FreeRider has to know where to place a lot of lines and power-ups, but just storing them in a raw list of coordinates would take up way too much space. So instead, FreeRider uses a compression system called base32. A number's base is the number of digits available to represent that number. For example, we use 10 digits, 0 through 9, so we use the base 10 system. As the number you are trying to represent gets higher, the current digit gets higher and higher until it reaches the last digit that it can use. At this point, 1 is added to the place to the left, and the digit you are using resets. In the base 16 system, which you're probably familiar with if you have ever used hexadecimal colors, there are 16 digits. Just like in the base 10 system, as the number gets higher, the current digit gets higher until it reaches the end, adds 1 to the place to the left, and resets. The base 32 system that FreeRider uses works the same way as the base 10 and 16 systems. The only difference is that instead of having 10 or 16 available digits, it has 32. This means that really large numbers can be encoded in really small spaces. FreeRider uses these base 32 numbers to encode the X and Y coordinates for everything. Alright, so now you know how the coordinates work, and how base 32 works. But how does FreeRider know what it should put at what coordinates? Every power-up has its unique one-letter identifier, which you can see here. To encode a normal power-up, for example a checkmark, first the unique identifier is put into place. Then the X and Y coordinates are put after it, separated by spaces. Finally, a comma finishes off the checkmark to let the game know that we are done and it can go looking for more power-ups. The X and the Y coordinate must then be encoded into base 32. Power-ups that rotate, like boosts and gravity changers, have a third value that is tacked on to the end. This value represents how much the power-up is rotated in degrees, with 0 degrees being pointed straight up. The X and the Y coordinate must be encoded into base 32, as well as the rotation value. Vehicles, such as balloons, follow a different format entirely. They start with a capital V, and then a number which represents the vehicle type. The vehicle's X and Y coordinates come after the vehicle type, and everything is closed off with an A and a comma. For vehicles, just the X and Y coordinate must be encoded in base 32. The last thing that needs to be encoded are lines. Lines are not encoded in the same way as power-ups or vehicles. They do not have an identifier like everything else. They have two coordinate pairs and they end with commas. Just like everything else, they are encoded in base 32. FreeRider is able to tell the difference between physical and scenery lines and all the power-ups by simply placing them in separate sections of the stored track. Each section is separated from the rest by a hashtag. These hashtags stay in place even if the sections they separate are totally empty. Alright, to recap. First, coordinates are encoded using base 32. Second, power-ups and lines are put into the correct format. Lastly, physical lines, scenery lines, and power-ups are sorted into their own categories, separated by hashtags. You can see an example of a stored track on screen now. If you want to start programming for FreeRider, there are several projects that allow you to easily work with a FreeRider encoding system already online. These two projects use JavaScript and Python, some of the most popular programming languages today. If you like Rust, there is a library available, but it is currently out of date and not totally feature complete. I'm currently working on a library that will replace this older one, but I don't have a timeline for release yet. Thanks for watching, and happy writing.